Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, today we are going to start with chapter number 18, the last chapter of your 9th standard syllabus for the subject of Science 2. Chapter number 18, Observing Space Through Telescopes. Okay, so this is the part we are going to discuss in this chapter, like forms of light, telescopes and types of telescopes, telescopes in space, and we are going to talk about Indian Space Research Organization ISRO. Okay, so let us start. From early days, man has been curious about the sun as well as the moon and stars seen in the night sky. Using his boundless imagination, he tried to understand the sky as observed by the naked eyes. He noticed the position of stars change with time had something to do with occurrence of seasons. As the knowledge of cycle of the season was necessary for agriculture, sky watching began to prove useful to him. The position of constellations was also useful to sea goers for navigation. Man began to make determined efforts to find answers to some questions which arose out of his sky watching, but he did not have any equipment to get a closer view of the stars and planets in the sky. So, since many years and years, man, which is a most intelligent creation of the Almighty, has been curious to know about sun as well as the moon and the stars which are present in the sky. And through his imagination, man tried to know about the things present in the sky and the space, and in this effort, in this process, many new things got invented and that helped man to go in space. So today, 400 years after Galileo use of the telescope, tremendous progress has been made in telescope technology and in space science and technology on the whole. This great leap in technology has helped to construct for us outstanding picture of our universe. Space science and technology are not only important for research purposes but also to help provide us with many of the comforts and facilities we enjoy in our everyday life. A telescope is used to observe space, but one telescope be sufficient for us to observe space completely? Why do we need different telescope for the purpose? And our telescope is installed even in space. In this chapter, we are going to study the science behind many such questions. So, after the Galileo invented the telescope, the person Galileo invented the telescope. So after 400 years, still today we are in that position that we are using this telescope but in more advanced way, in more modern technological way, and we have reached in the space to understand the space science. Telescope is helping us to a lot extent. So let us understand about the different types of telescope in this chapter. First we'll understand about different forms of light. What are the different forms of light we have in our nature? So light is actually an electromagnetic wave. Every wave has a characteristic wavelength. Our eyes can see the light which have wavelength between 400 to 800 nanometer, called as visible region. Such light is called visible radiation. However, there are electromagnetic waves of wavelengths other than visible ones, most of which we cannot see as our eyes are not sensitive to them. Okay, so there are lights which are I cannot see. Some eyes rays or lights like radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. Okay, so these are the wavelength of this. All waves, our eyes can see only visible rays, okay, of the line range 400 to 800 nanometer. Okay, so of all the types, our eyes are only capable of seeing visible radiation. Thus, we use the visible radiation telescope, that is optical telescope, made from regular lenses or mirrors to see the visible radiation coming from the space. However, many heavenly bodies emit radiations other than the visible light. Right? So there are heavenly bodies in the space which emit radiations other than visible light. Thus, we need different types of telescopes like X-ray, gamma ray, radio telescope to receive such radiation and to study their sources. So we have different telescope for different radiations. Now, if you talk about the normal optical telescope, so this is how telescopes or optical telescopes internal arrangement looks like. So most optical telescope are made with 2 or more lenses as shown in figure 18.1 to collect the maximum amount of light coming from heavenly object. The objective lens should be made as large as possible. Okay, so these are the objective lens which are made as large as possible, and using the light collected by the objective, a smaller lens called the eyepiece, smaller one, called as eyepiece, produce a large image of the source. Fine. So light rays change their direction as they enter a lens from the atmosphere, and again when they enter the atmosphere after passing through the lens. This is called refraction. Okay, refraction. The changing the path of light is called as refraction. So you can see in the dotted form, they're changing the path, and such telescopes are called as refracting telescopes. Okay. Now, even though such a telescope is useful for space observation, it presents certain difficulties. There are certain difficulties as well. What are those difficulties? Let us understand. The difficulties, like as we saw above, if we wish to obtain a bright image of a source by collecting maximum possible light, the objective lens must be as large as possible. However, it is very difficult to make very large lenses. Also, large lenses are very heavy and tend to get distorted. Such large lenses are heavy and may get, break, it may get distorted, the shape may change, difficult to handle. And as the objective and eyepiece are placed at the opposite ends of the telescope, the length of the telescope also increases with increase in the size of the lenses, and telescope becomes difficult to manage. Okay, even it is becoming difficult for the telescope to manage. So this is another difficulty. The images formed by lenses have errors of colors. This is called chromatic aberration. They also show different colors. So to overcome these difficulties, what one should do in this case? So to overcome these difficulties, telescopes are made using concave mirrors. Okay, so there are two kind of mirror, concave and convex. So here concave mirrors are used. As light rays get reflected by mirrors in these telescopes, they are called reflecting telescopes. Reflecting, not refracting. Okay, it's called reflecting telescope. In order to get bright image of source, large mirrors are necessary so that they can collect large amount of light from the source, but it is easier to make large mirror as compared to lenses. Why? Because big mirrors can be made by combining several small pieces, and the weight of large mirrors is too less as compared to lens of the same size. The images formed by mirrors do not have errors of colors. Only by using this large telescope can we see far away stars, galaxy which could never have seen using our naked eyes. The reflecting telescopes are mainly of two types, Newtonian and Cassegrain. So instead of reflecting, we are going to use here reflecting telescope, because mirrors are easy to handle as compared to lenses, and they are lighter. So here we are going to discuss now two other telescopes, Newtonian and Cassegrain. So reflecting telescopes are of two types, Newtonian and Cassegrain, as shown in figure 18.2. Light rays come from the space. Okay, this is the source. Light falling on the concave mirror, they come from the space. Okay, and they are getting fall on the concave mirror. Before this reflected rays converge at focus, they are deflected. Okay, they get deflected, they go back, deflected by a small plane mirror. Okay, there's a plane mirror kept over here, they get deflected. As a result, they get focus at one point. Now they get focus on one point, lying on the perpendicular axis. Okay, this is perpendicular. They pass through the eyepiece and we get magnified image of the source. So here they get deflected, they fall on one particular point, and here the eyepiece shows the image of that source. Now construction of Cassegrain, that was of Newtonian, and now we are going to talk about Cassegrain. The construction of Cassegrain type of telescope is shown in figure 18.3. The Cassegrain telescope also use concave mirror. Okay, there is a concave mirror, and these are where the light get fall on the concave mirror from the source. However, here light rays after reflection from the concave are reflected back. So they are reflected back to convex mirror, a small convex mirror. They pass through a hole. Now they keep some space empty. Okay, so there is a hole at the center of the concave mirror, and through that there is eyepiece which is kept exactly in between this hole, and the eyepiece gives magnified image of the source. So you can see light falls on the concave, was reflected back at the convex mirror, and then there is a hole. That hole have eyepiece in between, and that gives us the magnified image of the source. Okay, so this part is being omitted, not to be done, this part. Okay, moving ahead. Now we have radio telescope as well. Okay, so this radio telescope, mainly it is used for heavenly objects which emit radio waves in addition to visible radiations. We cannot see this radiation as it was told to you. Hence, a special type of telescope is used to receive these rays. It is called radio telescope. It is made from one or more dishes of particular parabolic shape. As in optical telescope, the incident radio waves are reflected by dishes and converge at the focus. So there are dishes, you can see here. A radio receiver is placed at the focal point. The information gathered by this receiver is passed to a computer which analyzes it and constructs an image of the source. Okay, so you can see here. So there are images, there are receivers pointed at this dish, and they collect this and they pass on to computer. Okay, see, yes, here you can see they get converge at this receiver pass on the message to computer. This is how radio telescope works. Now we have telescopes at space, telescopes in space. Visible light and radio waves emitted by heavenly bodies in space can pass through Earth atmosphere and reach the Earth's surface. So optical and radio telescope can be erected on the surface of Earth. However, these Earth-based telescopes have some problems in making good quality observations. What are those problems? The visible light coming from a heavenly body has to pass through Earth's atmosphere to reach the Earth's surface. Now during this journey, some of the light is absorbed by the atmosphere and the intensity of the light reaching the Earth's surface decreases. A second problem is caused by the changes in atmospheric pressure and temperature. This changes causes a turbulence in the atmosphere, which in turn causes the light rays to change their path slightly and thereby shake the position of the image. So we don't get clear image by the telescope which are placed on the surface of Earth because of Earth's atmosphere. It causes changes in the position of the light. Also because of sunlight, we cannot use optical telescopes during the day. During the night too, city lights and cloudy weather can cause difficulties in observing the heavenly bodies. And to reduce these problems, optical telescopes are situated on top of mountains or at uninhabited places. So in order to have a clear image, so telescopes are placed at the mountains or the place which is inhabited, no one lives there. However, if you want to get rid of all these problems completely, we should place a telescope above Earth's atmosphere. This is the best way, that is in space itself. So these problems do not exist in the space, and thus the image obtained by the space telescopes would be bright and very clear and will remain at one place. So scientists have turned this idea into reality. This has happened already. So these are the two. Just go through the name: Hubble telescope, because even this part got eliminated, and Chandra. So just for the namesake, you remember Hubble and Chandra. These are the telescopes which are there in space. Now let us talk about Indian Space Research Organization at Bengaluru, situated at Bengaluru. This is our country's space research organization. In short, it is called as ISRO. So this institute was established in the year 1969 with aim of developing technology for making the launching of artificial satellites. So till date, ISRO has successfully launched a number of satellites. ISRO's program is foremost among the successful programs undertaken by independent India, and India's progress in space science has played a big role in national and social development. So the INSAT or the GSAT series of satellites support our telecommunication network, television broadcasting, meteorological services. It is because of them that telephone, television and internet services are available everywhere in the country. The EduSat satellite in this series is used exclusively for education. The IRS satellite series is used for monitoring and management of natural resources as well as disaster management. Okay, so this institute is working, this organization is working for our country. Not only for our country, even the foreign countries are taking help of ISRO to send the satellites in space. So we are really proud of this organization of our country. Now if you talk about the Astroset, one of the satellite which is launched by this ISRO in the year 2015, Indian Space Research Organization launched an artificial satellite called Astroset in space. This satellite has ultraviolet and X-ray telescopes and detectors. Most of the parts used in the satellites are made in India. It is a unique system, have different kinds of telescope on a single satellite, and Indian scientists are studying various aspects of the universe using the data obtained with this satellite. Okay, so this is how we have finished chapter number 18. Now inshallah you will get all the exercise questions answered in the WhatsApp group. I am going to forward chapter number 17 as well as chapter number 18 exercise question in the WhatsApp group very soon. Okay, so go through your WhatsApp group, class WhatsApp group, you will get all the answers of the question. And here we have finished the portion for the next practice test, which is going to start inshallah from 2nd of April. All the best for your exam, study well. If you have any doubt, you can ask me in your group. Assalamu alaikum wa rahmatullahi wa barakatuh.